persistent XSS. But for persistent XSS, no tools in the market are able to scan for this. So you scan, you run an automated scanner, and you have a Form A that takes an input and Form D that actually displays it. An automated scanner today will not find that. One of my recommendations for that is, actually it is a pretty easy thing to do, is when you write your fuzzer, to remember what things you fuzzed for, and then later if you see it again, you mark it as cross-site scripting. So let's see what happens when it comes to static code analysis. You run a code like this against a static code analyzer, and it'll tell you with 100% assurance that I found cross-site scripting, right? Because this is non-persistent. We have a parameter that's been put into a string and then echoed back in HTML. Fairly simple. Now look at the persistent example, right? This is where code analyzers go for a toss. You have something that comes out of a database and then echoed back into HTML. Well, code analyzers don't parse SQL, so they have no idea if cross-site scripting is really happening. For all they know, you could be pulling things out of the database. It could be numbers, right? And consider the case where application A takes in data and application B pulls it from a database and displays it. A code analyzer is never going to catch that flow. It is clear that in the two application scenario, the application that's doing the output is the one that's vulnerable. But from an assessment perspective, where you're trying to find risk and trying to figure out if XSS is really taking place, a code analyzer is not going to do a good job of finding persistent cross-site scripting, which I think is a pretty big deal. The reason I bring it up is, if you look at the statistics, cross-site scripting is the #1 attack vector across the board for all applications. And yet, code analyzers are not able to do a good job for persistent XSS. And when you open up the marketing brochures for all these tools, nobody will tell you that. So in the persistent case, you have a code analyzer reporting a suspicion that there might be cross-site scripting. Now you take this scenario and apply it into an enterprise level application with 1 million lines of code, you'll have 5,000 suspicious things that the code analyzer will report to you. Now, the usefulness of that has just greatly diminished, because now you have 5,000 different things to look at. And I think the reason, one of my big beasts for automated tools these days is the requirement, I think perhaps from the marketing department or from the sales department, that these tools be so easy to use that really actually makes them less useful. If I were to write a code analyzer, the simplest thing is, before you run static code analysis on a piece of software or a piece of source code, make the analyst tell you where is the anti-XSS function, right? It's actually extremely simple, and we'll see in the case of XSRF that the only way to detect XSRF automatically is to make the analyst give you more input before starting the scan. I think we mentioned this. So cross-site request forgery, perhaps most people in this room already know it, but just in case, is really where you force a user's browser to perform transactions on another established application sessions without the user's knowledge. So take, for example, a malicious site at shady.example.com, and let's just say you browse to that website. And the HTML that is sent to your browser contains this, this piece of code where you have image source equals somebank.com/transaction.cgi, amount parameter, a really big number, and to account, the hacker's account number. Let's also assume that you have another browser tab open and you're logged into somebank.com. Your browser thinks it needs to load an image. It connects to somebank.com, realizes it already has a session established, sends the appropriate session cookie, and then performs the get transaction, right? Somebank.com, the application there, looks at the transaction and says, it has no way of understanding what's going on. The application thinks it's the user trying to perform that transaction, and lets the transaction happen. That's, in a nutshell, is what XSRF is. The Yahoo mobile example, a month ago, I noticed that when I was logged into the full-fledged Yahoo application, and then I pointed my browser to wap.oa.yahoo.com, it showed me this application, which is really a skinned-down version of Yahoo services to fit on your smartphones, your PDA, or your cell phones. And the interesting thing was, if you're logged on to the full-fledged version and you point your browser to this application, you're automatically logged in. They shared the same session cookie, session ID. And then I noticed there were two XSRF attack vectors in the IM and the calendar that were vulnerable to XSRF. So if you have a malicious code like this in your malicious site, anybody who visits your site will be kicked out of his Yahoo session. If you have an invisible iframe with code like this, your malicious site will be able to add arbitrary entries on the Yahoo user's calendar. So let's look at an example. Here you have the victim logged into the IM session and the calendar. Now he or she is going to go to a malicious site, and the victim is immediately kicked out of the IM session, so that's XSRF number 1. And then when the victim goes back to calendar, he or she will realize that there are arbitrary calendar events that they didn't add, but was added by the malicious site. The interesting thing is, when I emailed Yahoo and I told them about it, of course they emailed me back and said thank you very much. The next day when I went to the mobile version of their site, I realized that the calendar service, they just took it offline. So that's one way to guarantee 100% security, is just to take it offline. I think if everybody in this room takes a pledge to report one vulnerability each to one of Yahoo's each applications, tomorrow when we go there, it'll be a blank page, right? Preventing XSRF, the worst thing you could do is rely on post. The calendar example we saw actually used post request to perform XSRF. Relying on the referrer header is also a pretty bad idea. There are some plugins that may allow you, a malicious user, to forge the referrer header. A good way to prevent XSRF is to use random tokens. When a user logs in, pick a really big number and assign it on the server side to that user, and expect that token to be sent to you for every get or post transaction or important transactions. Now, most of the efforts for XSRF have been done on the server side. There are people in the research community who started to ask, well, shouldn't the browser be doing something to help prevent XSRF? I think that's an interesting problem. But the problem with that is, you have things like cross-domain images. I mean, when the World Wide Web was developed, that's always been fair game. It's been annoying for people who leech off resources, but posting across domains is also fair game. But I did come across a paper and a tool called Request Radio by Martin Johns, and I think Martin is going to be talking here at 2:30. So if you're interested in the topic of client-side XSRF protection, you could come to his talk. The reason I brought up the Yahoo example, I mean, I don't think it's finding XSRF is so common, you could probably find XSRF in most applications on the internet. The reason I brought up Yahoo as an example is because I think it illustrates the concept of cross-application, cross-site request forgery. So let us understand what happened. You have the innocent user that made a GET request. The malicious site sent back an XSRF payload, right, which caused the innocent user's browser to make a transaction on the mobile section of the site, right? And as soon as that happened, the mobile section persisted the data into the database. The interesting thing here is, because of this attack, when the user actually went to the full-fledged version, the data he had in the full-fledged version was also affected, right? So the point I'm trying to bring across is that of risk today in applications. Risk is no longer at the application layer, it's at the data layer. So I'm speculating here, but just to drive my point across, I could almost speculate an executive or a business owner in Yahoo saying, well, millions of people use the full-fledged version of our application, so let's spend more money doing assessments and code reviews for that version. Let's not worry about the mobile version because not too many people use it. And I think that is flawed, because the risk is at the data level. So the way it should have been done is take a look at the data you have and say, this is high-risk data. We cannot lose this data. This is our customer's data. All applications that write or read to it are also high risk. It doesn't matter how many people use it or not if they're facing the internet. That's the point I wanted to bring across. So assessing for XSRF, no tool that I know of, at least commercially, will assess for XSRF automatically. Before I left for VN, I did see a press release from AppScan saying that they have some beta version where they will assess for XSRF. I can't talk about that because I haven't seen it, but I'm not holding my breath. Reason for that is, take a look at these two URLs. Let's assume both of them are vulnerable to cross-site request forgery. You have one that performs something called actions equals hello, kind of seems like a hello world thing, and then the other URL that performs actions equal delete user. It is clear that for the delete user example, you don't want cross-site request forgery happening if you're the owner of this application, right? Now, if you point an application scanner with zero knowledge, the way vendors like to sell them, an application scanner is not going to be able to differentiate between these two actions, right? Same thing for code analysis. No static code analyzer has the ability to find for XSRF. How could they? I think is extremely easy. You make the analyst point out important actions, or the analyst can say, all get and post requests on my application must be protected against XSRF. Here is my anti-XSRF token, or in the case of a code review tool, here's my anti-XSRF method. If you don't see it being invoked during important operations, alert it as XSRF. So speaking about XSRF, it can be abused from an impact perspective to perform transactions on an intranet site, thereby blowing open any firewall rules you may have. So to illustrate, let's assume that there's an innocent programmer in the Google's intranet, and he performs a GET request to the malicious site. The malicious site returns back an XSRF payload, which in this case is going to make his browser connect to corp.google.com and issue the action self-destruct. And so as soon as that happens, corp.google.com will self-destruct, right? So this illustrates how XSRF can really be a bad thing for the intranet. It can actually set your machines on fire. No, I'm just kidding. When it comes to cross-site scripting, when you mix cross-site scripting, especially persistent cross-site scripting, with XSRF, an interesting scenario occurs. Of course, the probability of what I'm going to show you is admittedly slightly lower, but I think it's an academically interesting attack vector. Let's assume you have an application on your intranet running on 10.0.0.1 that is vulnerable to XSRF and persistent cross-site scripting. And you have another application on 10.0.0.2 that is vulnerable to XSRF. What can an attacker do? Let's say you have an innocent CSO who's going to be the victim this time. He connects to the malicious site. The malicious site sends back a payload that abuses XSRF and then uses XSRF to insert persistent cross-site scripting into 10.0.0.1. So what ends up happening is, from now on, anybody who connects to or browsers to 10.0.0.1 from the internet will be sent back an XSRF payload and will end up performing a transaction on 10.0.0.2. So basically, you have persistent XSS can end up making XSRF persistent as well. Now that we're talking about XSRF, which is really abusing the browser to perform transactions you don't need to, let's talk about what it means as an application owner. I'm assuming you're responsible for securing an application in the company you work for. What does it mean to you when web browsers and plugins have vulnerabilities? One of the advantages you have as an application owner is when you find issues in your application, at least you can fix them, right? But when you find issues or somebody else finds issues on a web browser,